Okay, here we go. We have a parabola here. We're going to do this one first. Get rid of the 1, make it a 12. I wrote a bad problem. We're going to go with 12x plus 12 is equal to y minus 2 quantity squared. We're going to pick up from yesterday. And we start with this idea. Do you recognize whether this is going to be a parabola that opens up horizontally or whether it opens up vertically? It does open up horizontally. Why? Because the y is being squared. You're going to be able to solve for x so that you have a y squared. So you're absolutely right. This is going to be horizontal. So I'm going to solve for x. I have 12x is equal to the quantity y minus 2 squared minus 12. I divide by the 12. X equals y minus 2 quantity squared minus 1. So it is a horizontal parabola. Let's identify the appropriate characteristics. We start with direction and vertex and axis of symmetry and focus and directrix, and finally the length of the lattice rectum. I forgot. When I first made this problem. Oh, thank you. Yes, thank you. 112. Thank you. I divide through by 12 instead of writing y minus 2 quantity squared over 12. We write y or x equals 112 times y minus 2 squared minus 1. So what is the direction? You said it opens up horizontally. It's going to open up to the right or to the left? It's going to open up to the right. Why? It's positive and it's horizontal, so open up to the right. Any question there? Okay, now here's the confusing part. What is the vertex? The reason why, yep, exactly. So the vertical shift is now inside here. So the vertical shift is 2. The horizontal shift is -1. I'm going to plot that. I'm going to make an 8 by 8 chart here. I'm going to try to make a perfect parabola again today. You guys can be my judge. Vertex is -1, 2. Back 1 up 2. Is the axis of symmetry going to be vertical or horizontal? Horizontal, the axis of symmetry is going to be the same as I have the first 3 in place. I just need to name the axis of symmetry. Is that x equals or y equals? Y equals. It's a good way to remember if it's x equals or y equals. If it goes through the y-axis, it's a y equals. If it goes through the x-axis, it's x equals. The focus point. What do I need to figure out in order to do focus and directrix and length of lattice rectum? P. How do I figure out P? Very good. A equals 1 over 4P. What is P? 3. Now what? So what? P is 3. What does it even mean? Yeah, if you look at the shape on the board over there, you can see the focus sits on the inside. How far from the directrix, or how far from the vertex? P units. And how far on the outside does the directrix sit? P units. So I move 3 units to the inside. What's the location of that focus? 2, 2. I move 2 units to the outside. Is that a point or a line? It's a line. It's going to be perpendicular to the axis of symmetry. That's an equation of x equals -3. The length of the lattice rectum, absolute value 4p. 12. So I'll move 6 units on each side, which will make a total of 12. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Olivia, you just asked a question. Sounds like you answered it. Is that true or no? Please ask. Go ahead. What was your question? Okay. So we use this equation. Looking at this parabola, we see we have 1 over 12. That's our a value. So our formula for finding p is a equals 1 over 4p. Cross multiply, you get 4p is 12, p is 3. Good? Any other questions before we finish this off? Grant. Oh, thank you. Yes. Because I moved back 3 units. And from -1, that would bring me to x equals -4. You're absolutely right. Did somebody else catch that and just not speak up? Say shame on you guys. Okay. So there I go. I have the lattice rectum. I will start at my vertex and I will start to generate the graph. So what I'm going to do is now see if I made a perfect parabola. Any point on the parabola should be the same distance from the focus as it is from the directrix. So I'm going to draw another line from here to the directrix. Right about there. What do you think? Well, which one? Do you think the blue is longer or the black is longer? Okay, Olivia's saying the blue is longer. Well, that takes some effort, folks. I mean, that's pretty good. One of the challenging things about doing it on the board is that you're drawing sideways a lot. You got to try to, look at it straight on. So anyway, all right, let's do our last one. You have the rest of the time to work then. Direction, vertex, axis of symmetry, focus, directrix, and length of lattice rectum, and then obviously our graph. Is this going to be horizontal or vertical? What do you think? Vertical. Why, Natalie? There's an x squared, so I should solve for x equals or y equals? Y equals. So I have 7y is equal to -4x squared. Thank you, Jackson, for your emphatic response. Just making sure we're on track, right? Yeah. You're a funky looking fraction. All right. So the math comebacks are always the hardest. Nobody wants to look like a funky fraction. Okay, direction, up or down? Because you said it was vertical. You're right, it is down. Vertex. Hey, isn't that awesome? kind of cleans things up for us a little bit, right? That 0, 0 makes it a little bit easier. So I think a 4x4 graph should suffice. Sweet. So I got the center at, or the vertex at 0, 0. Axis to symmetry, vertical or horizontal? Vertical. What's the equation for the axis of symmetry? X equals 0. Okay, that's all review. As we move on to these next three, what do I have to do? Find P. A equals 1 over 4P. So negative 4 over 7 equals 1 over 4P. Cross multiply. Negative 16P is equal to 7. So P is, which is about how much? About negative a half, right? It's about. No, just as we graph it, that's going to be a challenge for us. So we'll actually use the negative 7/16. But if I move negative 7/16 units, I'm going to move that about half of a tick mark. Just try to go maybe a little bit less than half of a tick mark. So what's the location then of the focus? Very good. The directrix will be in the opposite direction, and that's going to be a horizontal line through that point. So that would be, and the length of the lattice rectum, absolute value of 4 times negative 7/16. 4 over 16 reduces to 1 over 4, so we have 7/4. So 7/4 is 1.75, but if we think of 7/4, we need to split it in half to decide how much to move in each direction. What's half of 7/4? 7/8, right? So 7/8, which is about 1, just a little bit short of 1, correct? So I'm going to move from my focus just a little bit less than 1 in each direction to make my lattice rectum. And now I'm going to draw the shape of my parabola. And I'm going to try to do my very best job to draw a perfect parabola. We'll see how good of a job I did. I'm fearing that this could be horrible. That was pretty bad to begin with. Because I can't twist and turn the line, it actually changes the shape. So I can do the line once, but I can't do it twice. So I'm going to use the line maker there. What do you think? And I'm definitely off. So, looks like I need to continue to practice. Third hour says they were going to put in a formal complaint to Mr. Grossclaw that I'm obviously not qualified for the job. So, yes. Instead of complaining about, say, my lack of organization or my insulting manners, you should complain about my inability to draw perfect parabolas. So, your assignment is the same as yesterday. There are no changes to it. Okay? Go ahead and get to work. You have more time than any other class to work today. You have about 33 minutes. But you're the most intelligent class, right? And so we just get through the lesson quicker. So